Okay, so in this class we'll do your test 13.8A portion, the first test in this exercise, 13.8. We'll start with the introduction and then go to those two questions, okay? So let's write down here, introduction. So in your introduction, we will discuss about the volume of a sphere, okay? Volume of a sphere, okay? Volume of a sphere. For that, let us do an activity, simple one, to understand or get a grasp of the formula that we're going to use, okay? So let us say we have a ball here, a sphere. Sphere is basically a ball only. So this is the sphere, let us say, whose radius is, let us say, r. So from here to here will be the diameter from here, r plus r, 2r, okay? So let us say this is your figure 1. Then let us put this one, means put this figure 1 inside, okay? Figure 2. So what do we mean by that? We take a cylinder which is of the same base radius, okay? So around this much. Okay, so this is the cylinder we're taking. So we have to make sure we take a cylinder such that it has the same radius as this sphere r. And from here to here, diameter is 2r, means the height should also be 2r, okay? And it is full of water. Okay, so full. So you can write here full of water, liquid water. So you put this one full inside. That means everything pushed it inside, so it is completely inside the cylinder, and then remove it. And then remove figure 1. Put figure 1 inside figure 2 and remove the figure 1. Then the picture of this figure 2, this is figure 2. The picture of figure 2, this is figure 2. Same figure. After you remove the figure 1 sphere out of it, you will find out that only 1/3 of the water is left, and 2/3 of water is displaced. The word displaced here means removed. This is the activity you will find. So what does this tell about the volume of a cylinder? Therefore, this tells us that a volume of sphere, volume of the sphere, okay? Volume of the sphere, which we are talking about is figure 1, this one, is equal to volume of water displaced, okay? Displaced by it. So remember this is the law of buoyancy, that when a solid is fully immersed in a liquid, it pushes up or displaces a volume of liquid equal to its own volume, means volume of the solid. So a solid, when put in liquid, will remove its own volume of liquid. So whatever volume of liquid removed is 2/3 of the total. That is the 2/3 of the total liquid that is out now. It's actually the volume of this sphere. That's what it means. So which is equal to, as you see in the figure, it is 2/3 of means into total volume of water is actually, it was full, means volume of the cylinder, volume of the cylinder, right? Which is in figure 2. So that will give you this volume of the sphere is 2/3 times volume of the cylinder, because the cylinder was full of liquid. So 2/3 times volume of cylinder formula in our previous chapter we have learned is pi r square h, volume of a cylinder. So let us apply that. R square, that is correct because radius is r, into h here is 2r. So let us put like that. So we're going to get 2 2s are 4/3. Here 2 2s are 4. Then pi r square into r is r cube. So today we learned we're going to use this volume of a sphere formula is 4 by 3 pi r cube. How we got it? We've seen through this activity. Okay, write it down and then let us go and start the exercise. Let me read the question. B1 subheading 1, let us say. Let me read the question. Find the volume of a sphere whose radius is 7 centimeters. So let us say this is a sphere here. So as we have said just a moment ago, sphere is nothing but a ball. So the radius from here to here is 7 centimeters. Here, this ball here that I'm holding in my hand is literally a sphere. This is a sphere, okay? Ball is a sphere. Okay, so this sphere here. So here, for the sphere given to us, r is equal to 7 centimeters is the radius, right? This is the radius. And you have to find the volume. Therefore, its volume will be equal to, just now we learned the formula, 4 by 3 pi r cube. Okay, now once we're through with that, then we can just write down 4 by 3 pi not given means 22 by 7 into r cube means here 7 has to be written 3 times, and volume is 3-dimensional, so centimeter cube. So once we are done with that, then it's just a matter of cancelling 7, 7, and nothing more goes. So let us just multiply them. This into 42 into 22 is 88, and 7 7s are 49. So when we multiply this, we'll get our numerator. So 8 9s are 72, 7 in hand. 8 4s are 32, plus 7 is 39. Same number, 2, 9 and 3, so add 2, 11, 13, and here 4. And this is your rough, okay? So 4, 3, 1, 2 divided by 3 centimeter cube. So we can write this one in the mixed fraction form. Our answer like this is so 4, 3, 1, 2 divided by 3 1s are 3, and 3 coming down, 3 4s are 12. 1 remainder, 1 coming down, 3 3s are 9, 10 11 2 22, 3 7s are 21, and then 1 remainder. So here quotient is 1 4 3 7, and then dash here, remainder 1 will go up and divisor will come down. This is called mixed fraction form, and we can write our answer like this also, like this is the textbook answer, okay, exact textbook answer. So this is the first one. Now number 2. Second one, the radius is given as 0.63 meter. 0.63 meter. So it's just a matter of writing here 0.63 meter is the radius. So its volume from here, you can write the same. And from here we can start doing this one. 4 by 3 into 22 by 7 into r is 0.63 into 0.63 3 times, so you have to write once more, and volume is 3-dimensional, so meter cube. Write it down. And here 7 zeros are 0, 6 is less than 7 means we put 0 first, then only this 263 will combine. 7 9s are 63, and 3 1s are 3, then 3 zeros are 0, 0, 3 3s are 9. So we may as well multiply these two and see. 0.63 multiplied to 0.63, 3 3s are 9, right, and 3 6s are 18, then 6 3s are 18, 1 in hand, 6 6s are 36, 37, and 9 here 16, so 8 9, and here 3. So these 2 gone, and let us multiply to this 1, 2, 3, 4. So decimal 1, 2, 3, 4. So it will be this one. Then 1 to 0.03. We have to multiply to this. 3 9s are 27, 2 in hand. 3 6 are 18, 19, 20, 2 in hand. 27, 29, 2 in hand. 3 6 is 9, 10, 11. And 0 need not be multiplied, just count the decimal places. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 1 less means put 0. This is the answer till here. Now let us do this too. 22 into 44 is 88. Let's just put that 8 and multiply. 8 7s are 56. 8 9s are 72, 7 in hand. 8 1s are 8 plus 7, 15, 1 in hand. 8 1s are 8 plus 1, 9. And 0, 0 you can put if you want. Then here same numbers, so 6, 5, 2, 5, 9, 0, 0. So 6, 11, 8, 7, 14, 10. And 0 if you want to put, and then 1, 2, 3, 4, 5, 6. So starting from here, go left, 1, 2, 3, 4, 5, and 6. So we're going to get here 1.0478816 meter cube. So approximately like your textbook answer, 1.0, and first, second, third place of decimal you see, then it's more than 5 or more than 5 means this will, second place will increase by 1, so 4 plus 1 meter cube. Approximate answer, approximately. So that is your answer for second one. Okay. Now let us go to B2. B1 is done. Let us go to B2. And that will conclude your part for test 13.8A. Okay. Question number 2, subheading 1. Let me read the question. Find the amount of water displaced by a solid spherical ball of diameter 28. The first one is diameter 28 centimeter. So this is the sphere. And the diameter is clearly given, means from here to here, 28 centimeter. Right? So having done that, let us see next one. Here, we can write here 4D ball, means the spherical ball. R will be equal to diameter divided by 2 centimeter, which will be 14 centimeter on cancellation. So we found the radius. Question is asking amount of water that can be displaced by this ball, meaning if this ball was pushed in the bucket fully, how much more water will be, how much amount of water will it push up? Displace means push up. So we know this principle from buoyancy that since a solid displaces, because sphere is a solid, its displaces its own volume of water when immersed. Immersed means put inside water, immersed fully. When everything is put inside water, it displaces its own volume of water. So because of this, we can easily find out the amount of water displaced. Amount of water displaced. Amount of water displaced by this sphere or by this ball, whatever you like to put, will be equal to its own volume according to this principle. So volume means this is a sphere, so formula will be 4 by 3 pi r cube. Right, so let us solve in the next step. So that will give you here equal to 4 by 3 into 22 by 7 into r is here 14, so 1, 2 and 3 times we write, and centimeter cube because volume is 3 dimensional. See here, radius is 14 So now we can cancel this. 7 2s are 14. And here 14 into 14 is 196, I think. Right, so 4 4s are 16, 4 1s are 4, 5. Here, so 196. So 196 into, let us say 2. 2 6s are 12, 2 9s are 18, 19. Okay, 2 6s are 12, 2 9s are 18, 19. 1 in hand, 2 1s are 2, 3. So this 392 will multiply this 2. 22 into 4 is 88. So let us write that down. 88. Let's try that. And then okay, excuse me. So here, let's try that down. So here, 8 2s are 16, 1 in hand. 8 2s are 16, 1 in hand. 8 9s are 72, 73, 7 in hand. 8 3s are 24, plus 7 is 31. 6 3 1 3, let us say. 6 9 4 4 and 3. So here we're going to get 3 4 4 9 6 by 3 centimeter cube. So 3 4 4 9 6 divided by 3 1s are 3, next 4, 3 1s are 3, next 4 again, 3 4s are 12, 2 remainder, then 9 will come, 3 9s are 27, 2 remainder, and 6 here. So 3 8s are 24, and then here 2 remainder. No more digits, so just stop and let us write the mixed fraction form like we did a moment ago. 1 1 498 dash remainder 2 divided 3 centimeter cube, like the textbook answer. Okay, so that is your answer for this. The last one, last question for this test portion, subheading 2. Here the diameter is given as 0.21 meter. Let's be careful with that. So here for the ball, the radius will be 0.21 divided by 2 meter, because radius is diameter divided by 2. So 2 zeros are 0, then 2 1s are 2, no in hand. 1 is less than 2, so we put point means 10. So 0, and then 1 remainder, see here, 0.21 divided by 2. 2 zeros are 0, right, point means here. Next 2 1s are 2. Okay, no remainder. Then next is 1. Less means, point means we're allowed to put 1 0. Right, so 1. And then if it is not going, then we put 0. Then 2 5s are 10. So 105 meter. Okay. Yes, so this is the 0.105 meter. Okay, so 0.105 meter. So let us do this. Since, same reason for everything, since a solid displaces its own volume, okay, its own volume of water when immersed fully, we can write down amount of water displaced by the same its own volume up to here, and this part we'll do together. Okay, so here let's write down 4 by 3, 22 by 7, R is 0.105, 0.105 into 0.105. Then meter cube, volume is 3-dimensional. So we write that meter cube. Next here, let us do that. Now 7 is going obviously, so let us try that. 7, zeros are 0, point. 1 is less than 7 means put 0. Then 10, 7 1s are 7, 3 in hand, 7 5s are 35. 3 1s are 3, then 3 zeros are 0, zeros are 0. 1 is less than 3 means 0 again, and 15, 3 5s are 15. Okay, so here, let us do like this. 4 5s are 20. And 1, 2, 3 decimal places. So 1, 2, and 3. So 0 point, this is what we will get when you multiply this and this. So let us use that to multiply here. Okay, keep that aside for some time. Let's do this too. Okay, so 0.105, 0.105, 25, 5 ones are 5. 5 zeros are 0 if you want to put, then 0 means we don't need to multiply, so we shift one more here, and 1 5s are 5, 1 zeros are 0, 1 and 0. So we can just add up 5, 2, 10 and 1 and 0. 1, 2, 3, 4, 5, 6. Start from here, 1, 2, 3, 4, 5 and 6. So it will come here. So this is the answer you're getting when you multiply these two. Let us multiply that to this one. This one multiplied to this one is this one. So let us multiply this here. 0.020 means this only, right? So multiply this to 22, you will get 44. 2 into 22, 44. Then 1, 2, so 0.44 up to here. This 1, 2, 3 multiplied 0.44. So you can just put it here 0.44 and that will be your answer. Everything is ticked now, so you've multiplied, except this 4 5s are 20, 2 in hand, 4 2s are 8, 9, 10, 4 1s are 4, 4, and then same 0, 0, 1, 4, and 4. 0, 0, 1, 5, 8, 4. Let's count the decimal places. 1, 2 here, 3, 4 is decimal. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So here we'll go count once more. 1, 2, 3, 4, 5, 6, 7, and 8. So this is your answer. So 0.004851 and 00 you can avoid writing if you want, meter cube, and textbook has given this as answer, so we just write it later, 0.004851. So that concludes your portion. Go and give the test. They'll be okay, right?